now that we know how to compute the Macaulay duration, how is it a measure of price sensitivity? Before this, I mentioned that the price sensitivity depends on Macaulay duration. Actually, the Macaulay duration can be used to measure the price sensitivity and hence measure the percentage change of price as yield change. So let's go back to the basic. Let's find the first derivative of price against the force of interest. So we have a multiple cash flow asset with multiples which we can split into many single cash flow assets, right? So for each single cash flow asset, present value is going to be as follows, right? E to the power of negative delta t. So if we differentiate this with respect to delta, then we will get as follows for each single cash flow. So we will sum up all of these derivatives, then we will get as such. Okay, so if we notice this familiar, right? This is basically the numerator of the Macaulay duration. So the numerator of Macaulay duration is the differentiation of the price function with respect to delta. So the Macaulay duration is simply the percentage change of price from original price per change of delta. So if you see, it is a percentage change of price, but when we look at our duration, it doesn't look like a percentage. It is like a numbers like 4, like just now we got 4.62. It doesn't look like a percentage, right? It won't be a percentage on its own. It is a measurement per change of delta. So this multiplier, if we multiply it with the change of delta, only then we will get a percentage of price. So that's why this we call it as a price sensitivity measure. It's a multiplier that can, it's like, so the higher the multiplier, the higher the price sensitivity. Moving on, modified duration. So we know Macaulay duration is a measure of price sensitivity against the change of delta or force of interest. But common measure of change of yield is change of I instead of change of delta. That's why we derive modified duration. Okay, let's first find the first derivative of the price function with respect to I. So if we solve it, you will get as follows. So the difference between this and the Macaulay duration's numerator is this part, this V. Other than that, is exactly the same. So that's why the modified duration is simply equals to the Macaulay duration times V. Okay, let's go to an exercise on an example. So a company makes a loan and receives level annual repayments from a borrower at the end of each year for 7 years. So here is the timeline of the repayments. So it's a level, so we don't know the amount, is not given, so the level repayment is X. So the effective rate of interest is 5.75%. What is the modified duration of the loan repayments? So we are asked for the mode. So we do the duration for Macaulay first, and then we convert it to the modified duration. So for the Macaulay duration, we know this is the formula, right? And because it is a level single cash flows, so this 80 you can easily remove. So Now we are left with just Vt to the power of t, and the denominator is the Vt. So if we simplify it, it becomes as follows. The numerator is increasing NVT formula, IA angle 7, and the denominator is A angle 7. Both is evaluated at 5.75%. So our Macaulay duration is 3.770. Okay, so once we know our Macaulay duration, what we do is just d mac times v is equals to the duration for modified duration. So we get 3.57.